Right, so let's get going on how the structure works. So after you've installed BlazeDEM, you're going to have a directory structure. This is just to show you on a Linux machine. I type ls and I can see the directory structure. So this top name that we have here, it's called BlazeDEM-GPU dev standard input. That could be something very different in your computer depending on which directory you extracted the files to. But in essence, after that, this structure is what will remain the same between the various installations. So there's a BlazeDEM folder, and that contains the binary. So the binary for executing the code. So that's how we invoke the solver. There's essentially projects, and that project allows us then to define projects, and then we can select which project we want to run, and we'll talk about that. There's in essence a results folder. So this remote systems temp files is some legacy folder. The results folder there is where the code results get stored to, and so that in essence allows us then to process the results once it's been ran. There's a scripts folder. There's a couple of scripts in them that allows us to do some post processing, and then there's the simulation of KSM file. Okay, so this is not a folder, but this is a file, and that file we can open up, and I'm going to just do that so that we can run through this directory structure quickly. So if I go and I open up this file in any browser that I want, so you can open up editor that you want, so you can use the editor of your choice. So we open this one up. I do mine inside Visual Studio Code. And in essence what we see is, this is now the file that's been opened up. We have a projects folder, and so there's a name associated with that projects folder. There's a world file name, and there's a name associated with that world file name, and then these are some parameters. So for now we're going to ignore these parameters. I really just want to focus on these first two things here. You see if I can change anything. Yeah, just focus on these two things here. So project folder, so if I go to that projects folder like we talked about earlier, I would expect to see something like called Tiltbox inside there. So let's go to projects, type ls, and then if I look there, I see there's two directories in here, polyhedral geometry and Tiltbox. And so in essence, that Tiltbox is the same as this name that we saw here. So they have to be the same. So that defines in that project folder which directory your project is stored in. That name of the directory is the name of the project. Then if we go into this project folder, Tiltbox, into that specific project called Tiltbox, I type in ls, I see there's a couple of folders in here again. There's materials, particle objects, surface objects, and world. And if I look at this next name, it says world file name. It should be full spheres. So if I go under world and I type in ls, I would expect to see something called full spheres, and there it is. So there's full spheres then essentially for the world file that we have. And that world file defines and sets up the whole project. And that is in essence, in short, how that first part of the directory structure looks. We're going to look at these projects in a bit more detail later, but this is just to show you more or less how the structuring works. If I now go and I go into BlazeDEM, into the binary, where the binary is stored, into the, call it the, so that's the executable directory, BlazeDEM. There is essentially Blaze. If I type in ls, so that's the project or the executable that I can run. So I can run Blaze. If I run Blaze, it will open up, in essence, for this project, define that it opens up the GUI interface for it. You can then start running the project, and you'll see there's a lot of text written to the screen. It's actually quite good to go and read through this. This is the main developer of the code, Nicola Govender, and in essence, this allows you then to see a lot of the technical details and what the project is all defined about. So this code, I've decided to run it at a time step of, I believe, 1e-5, but we'll see later on. We could have actually executed this a lot faster. But this is just to give you an idea that the code is executed. Once it's done, we can then essentially go to the results folder. Okay, so that's the results folder here. So if I go to the results, in essence, under Tiltbox, if I say now ls, I can see under the results there's a Tiltbox directory. I can then go to Tiltbox, and then I'll see there is the name of the world file under Tiltbox, full sphere. So I can have same project, multiple world files, and each world file will have its own directory for the results, and then full spheres allows us to see the results that are stored here. Okay, and we'll go through that in some later videos in detail. But this is just to give an idea of how the code is structured and how to get going on running your first BlazeDEM simulation.